We're going to look at how to find the inverse of different power functions, so like a parabola or a quadratic, a cubed, a fourth, a fifth, anything that has a power or variable raised to a specific number. Okay? So, for example, if I have f of x equals x minus 1 cubed minus 1. Okay? So, if the question wants us to find the inverse function, we're going to start by switching x and y. Remember, this is really y. It's a different notation that we have for it. So I have x equals y minus 1 to the third power minus 1 on the outside. Okay, so I'm going to first start by undoing the subtracting 1. Remember, we're going to do the order of operations backwards. So I'm going to start with the adding and subtracting here. So since I'm subtracting 1, I'm going to add 1. So I have x plus 1 equals y minus 1 to the third. There's no multiplying or dividing that I need to take care of, but I do have an exponent that I need to get rid of. So I need to get rid of the cubed power. To get rid of the cubed power, we're going to take what we call the cube root. Remember, the cube root has inside this little hook part a 3 that we refer to as the index. So the index is 3, and the cubed and the cube root undo each other. So I have the cube root of x plus 1 equals y minus 1. Now, originally in our problem, the y minus 1 was in parentheses. So we took care of the adding and subtracting first with the plus 1. We didn't have any multiplying. Then I took care of the exponent. Then we're back in the parentheses. Once you get to the parentheses, you start over with your order of operations. So I'm going to add 1. Now, the cube root and the 1 are not like terms, so I just keep it the cube root of x plus 1, and this 1 is still underneath, and then I do a plus 1 on the outside, and that equals 1. But we have this notation that we use for inverse of functions. We write as f to the negative 1 of x. But when we say it, we say f inverse of x. So now I've found my inverse. Now, if you're familiar with graphing cubes, this will make sense, but if not, let me just show you. A cubed power will look, this one specifically, will look along the lines of this. Now, notice if I were to run the horizontal line test on this, that it would pass the horizontal line test. So this power's inverse is a function. Now, if we take a look at a quadratic instead, okay, I have something like f of x equals 2x plus 5 squared minus 1. Now, your parabolas or your quadratics make a U shape. So, this parabola specifically would look something along the lines of this. If I were to run the horizontal line test on this one, notice that it fails the horizontal line test, and the inverse of this parabola is not a function. But if your directions say to find an inverse function, that's problematic because it wants us to have an inverse function. So what we do is we say, well, rather than look at the whole parabola that isn't going to be an inverse that has a function, I'm just going to look at half the parabola. So if I just look at this half of the parabola right here, if I were to run the horizontal line test now on the parabola, it passes the horizontal line test. So what I do when I do that is we have a domain restriction. So notice we started at negative 5. So I'm going to say when x is greater than or equal to negative 5, this is going to have an inverse function. Okay? So when I go to find the inverse, I'm going to switch x and y. Now you may be required to find the domain restriction, or it may be given to you. So if it was already given to you, they may have like a semicolon and then x is greater than or equal to negative 5, and it will say find an inverse function. Okay? I use fn for function. So when I have this part is just letting me know, hey, we're only looking at half the parabola. So they've made it so that you don't have to worry about the fact that it's originally not invertible. Okay? So I'm still going to start the process by switching x and y. So this was really y, so it becomes x equals, and then 2 times y plus 5 squared minus 1. So I'm going to do adding and subtracting first, so I'm going to add the 1. So now I have x plus 1 equals 2 times y plus 5 squared. Now I'm going to get rid of multiplying and dividing because that comes next in our Please Excuse My Dear Aunt Sally. Okay, so I need to get rid of multiplying. I'm going to get rid of multiplying by dividing. So I'm going to divide by the 2. So I keep x plus 1 over 2 equals y plus 5. Now on this one, I want to next get rid of the exponent. So, let's see, I dropped the exponent. Let's not do that. Okay. So I want to get rid of the exponent of the squared, so I'm going to take the square root. Now normally when you've taken the square root, you have to do plus or minus the square root, but because of this domain restriction and because we're only looking at half of the parabola, I'm only going to look at the positive square root. Okay? So I'm not going to put my plus or minus like we normally have done. So I have the square root of x plus 1 over 2 equals y plus 5. So remember, the squared and the square root undo each other. That's why I just have y plus 5 here. So to get the y by itself now, I start again with my add subtract because that was in parentheses, so I'm going to subtract 5. So this comes to the square root of x plus 1 over 2, and then outside of the radical I have a minus 5, and that equals our y value. Now, since y is alone, I can rename it to be f inverse of x. Okay? Now, please make sure that when you're finding the radical that you put the radical over the whole fraction if you have a fraction. Because if you had just like the square root of x plus 1 over 2, this is an entirely separate number than this would be if you plugged something in for x. Okay? So make sure that you have the root over the whole fraction. Okay? So anytime that you have an even-powered function, you want to restrict that domain so that you can have an inverse function. Okay? So for example, if I have h of x equals 1/3 x plus 4 to the 4th, so because this is a 4th power, I'm going to have to restrict my domain. I'm going to always restrict my domain to be the opposite of what's inside the power. So I'm going to have x is greater than or equal to, and then I'm going to change the sign to be -4. Okay? So if I had x plus 5 to the 2nd minus 1, my domain restriction would be x is greater than or equal to -5. If I had x plus 8 to the 6th plus 9, my domain restriction would be x is greater than or equal to -8. So see how I've taken the opposite of these ones? If I had x minus 9 to the 4th minus 6, here I'd take the opposite, so I'd have x is greater than or equal to +9. So if you have a negative, it becomes positive. If you have positives, it becomes negative. Okay? That's how you find your domain restriction. It's just the opposite of what's inside the power. Now notice it's only with your even powers, and that's because your end behavior for your even powers is either going to be going up, up, or down, down. So all of your like squared and 4th and 6th powers will look like this, and then they'll get steeper and fatter along the very bottom of the u part, the higher the power that you go. Okay? So I'm going to start by switching x and y. This is really my y value, so I'm going to have x equals 1/3 y plus 4 to the 4th. Okay? Then I don't have any adding and subtracting outside of the root or outside of the power that I need to take care of. So I'm going to jump to multiplying and dividing. This is being multiplied, so I'm going to get rid of it by dividing. If I divide by 1/3, since it's a fraction, I'm going to flip and multiply. The flip is called the reciprocal, so I'm going to multiply by the reciprocal. So I have 3, so 3x equals y plus 4 to the 4th. So to undo the fourth power, I take what we call the fourth root. So my index is just a 4. So the fourth power and the fourth root undo each other, and I'm left with y plus 4. So here I have the fourth root of 3x. Then, since this was in parentheses, I'm going to start over with my, please excuse my dear Aunt Sally, so I'm going to subtract 4. So I have the fourth root of 3x subtract 4 on the outside equals y. Please make sure that you're ending your radical where you need to be. Then it doesn't go too far and it doesn't go too little. So now that this is y, since we started with h of x, I'm going to call this h inverse of x. Okay. Now, if you have an odd power, you don't have to do this restriction. Notice here, theoretically you should be taking, anytime you take a fourth root, you should be doing plus or minus like you do with the square root. But because of this restriction, we only take the positive fourth root. So if I had like a fifth power, so say I had g of n equals negative 2n minus 1 to the fifth. Okay? So on this one I'm going to switch x and y, but my x in this case is n. So this is really y, so I'm going to have n instead of x equals negative 2y minus 1 to the fifth. Okay? I have nothing being added or subtracted on the outside, so I'm going to skip to getting rid of multiplying and dividing. So I'm going to divide by negative 2. So I have n over negative 2 equals y minus 1 to the fifth. So I'm going to take the fifth root now, which means my index and my root will be 5. So now the fifth and the fifth root undo each other, so I have the fifth root of n over negative 2 equals y minus 1. So I'm going to add 1 to the other side. So I have the fifth root of n over negative 2 plus 1 equals y. Now, it's unconventional to keep a negative in the denominator like this, so we're going to have the fifth root of negative n over 2 plus 1. So you may see it that way in a multiple choice test. The other thing that you may see on a multiple choice that I personally am not going to have you do, remember how we're not allowed to have roots in the denominator? So they may rationalize this and call this the fifth root of negative n over the fifth root of 2, and then rationalize the fifth root of 2 so I don't have any roots in the bottom. That becomes a little bit nasty, and I'm not really concerned about that, but that is something that you may need to pay attention to when you're taking like standardized tests. And then make sure that you switch this to be g inverse of n. Okay? So that's how you find the inverses of powers.